All right, happy Friday, everybody. Hope you're going to have a nice weekend here. I'm actually out and with the cyber range once again down there. We have a few meetings to take care of, some projects that we're working with next year. Also, I apologize if my audio isn't as good. Last video you saw, I was doing it from home, so I had my Blue Yeti, and here at school, I don't have the Blue Yeti available because it's at home. Okay? But I want to start off with just reviewing something related to inverse functions, and I talked about it in 6th hour, but I didn't really talk about it in 5th hour. And what that has to do with is the graph of the inverse functions. So if you remember from yesterday, this was f of x, 2x plus 3, and this was g of x, which is x minus 3 divided by 2. We talked about how they're inverses, how you've got a multiplication by 2, an addition of 3, and here you have a subtraction of 3 and a division by 2. Hello, just recording. How are you tonight? So I'm out tomorrow, so I'm making a video for the kids, so they don't ever get a day off. So, but now the thing I want to look at with is the graph, and so here's the graph of 2x plus 3. Here's the graph of x minus 3 divided by 2. And the thing to remember is that they are reflections of each other, and the reflection line is y equals x, which is this line right here, the 45-degree angle line. And if you think about that, hopefully that will make sense, because we reflect or flip over the line y equals x. And the whole idea about inverses is that we're flip-flopping the x's and y's. And I emphasize that at the beginning of this lesson because when we start dealing with example 2, problems like example 2 and problems like example 3, we got to think about what the reflection of the inverse looks like. So what does the graph look like when it's reflected over the line y equals x? Okay? So let's go ahead and take a look at this example 2, and let's talk about what we got to do to find the inverse of that function, how it relates to yesterday, because those steps come into play, but also because we have a domain restriction, x is greater than or equal to 0, and also that it's not linear. How do these things change what we did yesterday or add on to it? Okay, so first of all, we've got this function right here. We're asked to find its inverse. So that process is going to be exactly the same. So remember the process from yesterday. The first thing we do is we change f of x to y. So I say y equals x squared. And then I flip-flop the x and y's. So I now have x equals y squared. So this is the replace step. So we replaced f of x with y. And then this is where we switch them. The next thing that we need to do is we need to resolve for y. So what we have to do is take the square root of both sides. And remember, whenever we take the square root, we have to introduce the plus or minus. And so what we end up with when I square root both sides is plus or minus the square root of x equals y. So this is our resolve step. All right, let's go ahead and graph those two things. So I'm going to graph the y equals x squared, and then I'm going to graph the f of x, or excuse me, the positive square root of x and the negative square root of x, since we've got our plus or minus. Okay, so let's go over to Desmos. I think I got it. There she is. Whoops, that's not Desmos. Where are you? All right. So the first thing I'm going to do is I'm going to go ahead and graph the y equals x squared. Okay, and we should all be very familiar with that graph. But if you go back to the problem, it says that x is greater than or equal to 0. So you can see we've got a domain restriction of x is greater than or equal to 0. So it's really only this half of the graph. Cool thing about Desmos is you can do domain restrictions on it. So watch this. I'm going to do a little curly Q, and I'm going to say x is, oh, I got to find the greater than or equal to key, which, let's see if we can find that. It's right there. Greater than or equal to 0. Now look at what happened. Once we threw that domain restriction in, which was part of our original problem, it took the first half. So the graph that we're looking to find the inverse of is only this half. Well, what happens if I go ahead and I put in y equals the square root of x, and also y equals the negative square root of x. You can see that my inverse, which is technically both of these parts, is not like the original. It's double the original. So what we have to decide is what type of a domain restriction do we want to use on my inverse to make sure that it works. Another thing to think about, if you think about the graph, remember that the graph of the original and the inverse, they are flipped over that line y equals x. So which one of these, square root of x or negative square root of x, is a reflection of my original function over the line y equals x? Let's take a look at them. So let's get rid of this, or let's keep this. Let's get rid of this right here. And you can see that one's actually a reflection, because if I zoom in here, whoopsie, if I zoom in, notice that this piece right here reflects over and matches that piece. And then if I zoom out, oh, let's see, woo, boy, that'll get you dizzy. And you can see that this piece is the reflection of this piece. So notice that even though when we go through and we do our algebra and we get this as the inverse, we got to go back to the graph and we got to say, okay, what part of my inverse is the actual answer? What part did I compute that's actually the real answer of what the inverse is? And you can see that the negative square root of x is not a reflection across the line y equals x, but the positive square root of x is. So what does that mean? That means that as far as our answer, we don't want to leave it as plus or minus. We want to just have it as the positive square root of x, and we can go ahead and throw in our notation here. And the note, if you want to kind of put a little note, and this is what's extra, we need to do some restrictions. So I'm going to write restrict, and then what am I going to restrict? Since the original restriction, the original domain restriction, so since original restriction was x is greater than or equal to 0, since the original restriction was x is greater than or equal to 0, we only use the positive version. Positive square root of x, okay? Because it's greater than positive. Obviously, if it were less than or equal to 0, we would use the negative then. Let's go ahead and graph these so we can see the original. So the original kind of goes here, and then I'll go every other. And then I'll go like every one on here. So we have 1, 1. Actually, I'll go every other. 1, 1. 2 is 1, 2, 2, 3. So our original function looks like that. And then our final, what do you want to call that? Our final inverse looks like that. And you can see that if we have this line of y equals x, how it reflects over it. Okay? So you got to be aware of that when we're dealing with nonlinears and when you're finding some restriction, or when you're given some restrictions on this. Okay? All right, let's take a look at the third one then. It's kind of the same thing. So we're going to go through the same process. We're going to replace and switch to start with. So if I replace, I say y equals 2 times the square root of x minus 3. And then we want to go ahead and switch. So it's x equals 2 times the square root of y minus 3. So we've got our replace step. And then we've got our switch step. Okay. The next thing we want to do is we want to resolve. And so to resolve this, I'm going to first divide by 2. So I'll write it like that this time. And I have x over 2 equals the square root of y minus 3. And then I want to go ahead and get rid of my square root. So I'm going to square both sides this time. So squared, squared. Make sure when you square this, all right, make sure you square the top, and make sure you also square the bottom. So it's x squared minus 4 equals y minus 3. Okay, so we've got that. And then obviously we're going to add 3, so we get x squared over 4 equals 3. Okay? All right. So what are we looking at here? So let's go ahead and graph both of these. So I'm going to go ahead and graph my first one. So let's get rid of all of this. I'm going to keep the y equals x line there because that's going to come into play again. So I'm going to graph my original, and y equals 2 times the square root of x minus 3. So there's my original. It's kind of down there. And so now we got to look at what the graph is going to look like if I reflect it over that line y equals x, because that's the part that will be our inverse. All right, so let me go back here. I see a typo that I made. This should be a plus 3. Yeah, it wouldn't be a math lesson with a Mr. Lamb if there wasn't a typo. All right, so everybody got that? X squared over 4 plus 3. So let's go back to Desmos now. And I'm going to say y equals x squared divided, where's my divide? There we go, divided by 4, not that, divided by 4 plus 3. Now take a look at that inverse, okay? That inverse has both parts of the parabola in it, whereas our original only has kind of like a half of a parabola. So what we have to do to this one is we got to figure out how to restrict it so that I only have this half of the parabola, because from right here from right there all the way over here, that's the half that's reflected from here. Okay? So how am I going to restrict that to get just this half from here over? Well, think about what your x value is there. It's 0. And so it's bigger than 0. So x is greater than or equal to 0. So I can put that restriction on it, and look at what happens. Okay? I now have the half that I want. Okay? And if you think about this and think about what we said, it's a reflection of the line y equals x. This is our original. This is the line y equals x, and you can see that this in black is definitely a reflection over the line y equals x, the red piece. And so what we have to do in our answer, if we want this to be an inverse, is we have to place that restriction. So I'm going to take this equation right here, and I'm going to say f inverse of x equals x squared over 4 plus 3, but x has to be greater than or equal to 0. And as far as the graph, let's go ahead and graph this right here. This is your original right there. This is your new one right here. And if we have that line of reflection, you can see how, once again, it's a reflection. Sorry, my graphs aren't very good. So hopefully that makes sense. I want you to continue on with your assignment, looking towards what we're doing Monday. I think Monday will be real quick, so we'll have plenty of opportunities to answer questions. But go ahead and dive into today's assignment, which is on your agenda. All right, have a good one.